Because most of that vocab is going to show up in the study goals. And we are going to talk about study goals 18, 19. We'll come back later to 20. We'll do 21, and we'll probably flirt with 22, but I don't think we're going to get too far with that one today. We have like an hour and a half, just 3 study goals. My students are usually like, oh, come on, bros, get on with it. But I gotta warn you, we all, adults and kids, people my age, people your age, we all make a lot of assumptions that are incorrect about some petroleum stuff that affects all future conversations about petroleum. This gets back to all the upcoming elections and all economic matters, and like, this is actually a really big whoop. So I want to really baby step, and I want to make sure that we avoid some common mistakes. I think it's number 18 about introducing fossil fuels. This is supposed to be easy. I'm not trying to trick you, but it's not rhetorical. What are fossil fuels?
Chains of carbon.
Chains of carbon, yes.
Forms of stored solar energy.
Stored solar energy, this is kind of working. Why the fossil part?
Because they're dead matter.
Dead organic material, yeah, that's all accurate. Okay, so we got some dead organic material, that's the fossil part. And the fuel part is the
Solar energy.
solar energy, but it's no longer solar, now it is
Carbon.
carbon chains. Okay. We should probably just come out with this right away, up front. When we say fossil, we don't mean like the bones of the Tyrannosaurus Rex or whatever fossils. We mean it was like previously living stuff, but it may be worth noting that we're talking about single-celled algae, plankton, and little plant fibers, usually. Single-celled algae, plankton, little plant fibers.
That's what makes up the oil or the gas?
For the most part, yeah. Yeah. Now, I want to build a cheap visual. So this is, please look up, 1, 2, 3, 4, 5, 6 carbons, like you would find in glucose. I don't know if anybody here knows this thing. Ryan Murphy, thank you. I don't know if anybody knows this detail, but glucose is a hexagon, not a line. Okay, and doesn't really matter for today. Glucose has different bonds. Some are single, some are double. Doesn't really matter for today. It is 6 carbons. So here's my 6. Okay, hold on. Okay, one job. And here's another carbon. Okay. And, you know, heat and pressure, we take the dead stuff and we mash it all together and make a little fossil fuel, right? Like, you could take 2 C6s and mash them together and you get a C12. Good luck, Bill. Okay. Ooh. I'd like to build a visual for you. It doesn't have to be C12. Like,
15.
Yes, it could be C15. That, by the way, that's gasoline. Or it could be. Oh my God.
You're gonna need someone taller than that.
I don't think so. It could be C18.
Oh, you get up that tail.
That's diesel. Now. And it could be like C24, which I think is like home heating oil, or C50, which I think is what they put in jet planes, or like C70, which I think is what they put in the big tanker ships out there. You probably want to know that fossil fuels are a variety of carbon chains. It could be C1, it could be C2, it could be C4, it could be C whatever he's got now. Stuff happens, you know. It could be some C5, which is another, I forget what that's got a name. Or it could be methane, those are the C1s, or ethane, which is the C2. Are
the quality of gases the amount of carbon bonds they have?
Yeah, the different gases, methane, ethane, butane, propane, is C1, C2, C3, C4. At C5, it's no longer a gas. It's too heavy to float away, so it's a very, very light liquid called naphtha, which is really, really runny. It's like a crazy light liquid. C6, C7, 8, 9, those are all like precursors to chemistry. We use that to build plastics and pharmaceuticals and paint and stuff. At about C10, it becomes a fuel. Anyway, I don't really know these numbers. I'll give you the right numbers eventually. I have a slide coming up in a week. I don't give a crap. Well, we should just say yes, of course.
Okay.
You don't have to ask. Okay. Here's a couple of words that you probably want to have in your fossil fuel introduction. Variety of carbon chains, organic material, stored energy, when I say variety, you should probably know. Does everybody know what the 3 fossil fuels are that we use for energy as humans? The fossil fuels are, petroleum. What's the solid one? Coal. And then the solid, liquid, and natural gas, that's right. Those 3 are always blended together. And that's definitely something you have to know. When you find coal, there will be some petroleum and some gas. When you find petroleum, there will be some solids and gas. When you find gas, there will be a little liquid and a little solid. They're always mixed, because you're not always going to get one type of carbon bond. You're going to get some of the others. If you want a visual, imagine I've got a pillowcase full of Legos. Okay? Pillowcase full of Legos. And I tie that up or something, and then I start squeezing that pillowcase, and I add heat and pressure. At random, some of those Legos are going to click together, right? The most common Lego number will be single Legos. But you'll get kind of a lot of double Legos, and probably some smaller number of triple Legos, and a very, very small number of four Legos, right? And if I keep massaging the F out of that over the years, I'm going to accumulate more and more 5s and 6s and 7s. And if you really keep going until infinity, you'll just have one mega block of Lego. That make sense to everybody? They're just randomly forming bonds when they line up. Over time, you keep trying, you're going to click more of them together. Yeah?
So, say you have like a C2 or something.
Yeah.
Can you just get like 5 C2s and make a C10, or does it have to do it naturally?
You mean, can we as a human make that?
Yeah.
Yeah, we can. It just takes a ton of energy to do that.
Okay.
So you're going to spend more work than you're going to get work out of it, because
So
the
you
laws of
second law.
thermodynamics.
You can only use like C10s for gasoline, but there's only so many C10s that are already made.
Yep.
Okay.
The numbers are wrong, but the idea is right.
Oh.
It's C15 or something. But yeah, the idea is fine. Okay. A really basic introduction to fossil fuels. This was supposed to be easy and painless, and I'm assuming everybody already knew all of this. And you've all heard that we dig them up out of the ground, right? Like seams of coal and like pockets of petroleum and like pockets of natural gas, yeah? But the question is, how the heck does that happen? And there are so many misunderstandings in the next 20 minutes that I need to bore you. I am gonna shake you with repetition. I'm gonna bludgeon you with simple stuff over and over to make sure that you don't make the same stupid mistake that all the rest of us always make. So first of all, how much fossil fuel do I get? Like if I kill Rio and I smush him with a bunch of heat and pressure, how much fossil fuel is that?
None.
Not necessarily.
Let's assume I keep going until the carbons all get stuck together. What volume are we talking?
A teaspoon?
Yeah, we're talking like a golf ball maybe. Not a lot. Cup. How many of you are aware that we have petroleum underneath our coastline? Because of the rigs and stuff, please for God's sake, obviously everybody knows that. Okay, that deposit of petroleum goes basically to Port Hueneme. It's continuous all the way out to Point Conception, more or less. About 3 to 4 miles offshore, all the way underneath land, as much as 1 or 3 or 4 miles inland between Point Conception and Oxnard. So it's about 50, 60 miles by 4 to 7 miles. How did that happen? Like, that's not mushing a Rio.
Well, there was the plankton and stuff that lived in the ocean that got compressed over time.
Okay, so we're talking a lot of material, right?
Well,
Yeah?
It all just like forms at different times and kind of bunches together when it comes up.
Sort of, but in geologic terms, it kind of forms at the same time. Like, you know, within a few thousand years or so. But how do you pile up that much dead material? Do you all realize that one man's trash is another man's treasure in ecology terms? Right? Like, if I kill Rio and I take his handsome corpse and I throw it over the fence, that's not going to be fossil fuels. That's going to be worm food and rat food and raccoon food and seagull food and crow food, right? It's not just like all dead things become fossil fuels. All dead things become tomorrow's live things. Y'all seen those like documentaries about the landfills in Brazil where there's like villages of people that all sprout up on the edges to glean the life from the trash? So whenever you have a dead Rio, that's just a party for all the decomposers around that.
it has to be preserved somehow.
Yeah, and like how's that gonna happen? Because that's
A
really
volcano?
valuable. It's like buried treasure.
Could be like a volcano or something.
Okay, so yeah, we're gonna talk about big events, volcano or something. We're gonna come back to that. Let me just baby step through this because I want to make sure that we avoid all the dumb mistakes that we're all naturally gonna make. If I kill Rio and throw him over the fence, he's not gonna make it to the ocean. He'll be rat poop and seagull feathers within a few days. He's not gonna make it to the sea. If I could actually take some chunks of Rio and throw them into the ocean,
Fish food.
yeah, exactly. There's going to be like scavengers and the worms and the crabs and the sea monsters and mermaids and the Loch Ness monster down there. And the alien ships and the giant squids. Right? So there's decomposers here, there's decomposers there. Somebody in first period's like, yo, what about the slides? And like, yeah, okay, so you got a big ass fire, then you get a big old flood, and you get a bunch of mud. Guess what? There's still like worms and crabs, and the ocean currents are gonna fluff and blend all that stuff, and it still comes out.
Mass extinctions.
So you would think, okay, mass extinctions, right? But you know, mass extinctions, historically, they're not like everything dies all at once. All of those mass extinctions are like 10,000 years, 5,000 years. They're like millennia of die-off. It's not like whoop, and then everything's dead. There's plenty of time for decomposers to get in there. Yeah?
It's like a mistake, right? It's not like supposed to happen, it's just
Yeah, I actually really like that word. And actually, if you want to understand how fossil fuel deposits are made, it's really important to remember something, and you could write it down. Fossil fuel deposits are like a fluke of sedimentary rock. It's like a total never gonna happen 1 in a billion random event. Almost everything that's ever been alive is still part of something else that's alive. It almost never ends up in rocks. It's a total weird, like, how did I get in there? I know a guy that worked at a lumber mill, and he was milling a piece of wood and he found a handgun. Like, how does that get in there? That's what we're talking about. Like, there's a story, you know, somebody probably like shot someone and disposed of the evidence by putting it inside of a tree that grew around it, and then they milled it 100 years later, and there was like an old gun inside and shot pieces of gun through the lumber mill, and somebody got hurt. First, we're going to need a whole bunch of organic material, and here's a vocab word that is worth knowing. We call them depositional basins. Places on the landscape that fill up with organic material, depositional basin. It's in your vocab, it's part of the list. And it's like, you know, a basin, like a bowl or a sink that fills up with organic stuff. That was the worst attempt at a basket I've ever seen in my entire life. I'm pretty sure that you could have blindly behind your back, left hand is blindfolded, arms tied together, done better than that. That was bad.
That was really light.
So like, having the islands and then the mountains, so that create a depositional basin?
You've got the right visual. There's 3 depositional basins you should know about. Like swamps, wetlands and swamps, you know, that fill up with organic material from a whole watershed. Or bays that capture ocean sediment where the water slows down, it all settles in a bay. Or deep sea canyons, which I think is what you meant between the islands and the mainland. Yeah, deep sea canyons, that's right.
Wait, between the Channel Islands and here, there's a deep sea canyon.
Uh-huh.
What is the Arabian Peninsula?
Historically, I believe that the Arabian Peninsula was a bunch of bays, shallow seas. And bro, I'm not an expert, people do know, but I'm just trying to remember. Like, I'm pretty confident that the coal in Appalachia, which I guess is not Appalachia, or Appalachia, there it is. In the Appalachia Mountains, that was shallow seas and coastal swampland. So you've got your landscape of debris, and let's be clear, decomposers are working through it. So it's like a landfill, but that's being exploited. You know, deep sea trenches, they're full of little worms and filter feeders and feathery crabs and brittle stars. I don't know what the hell else, sea monsters. Oh, the fish monster from The Shape of Water. Did anybody else see The Shape of Water? Oh, you're such dorks, you're missing out.
Is that actually good? Because it's terrible.
It was actually unbelievably good. Who'd you hear was terrible from?
It's a movie about it, like, still picture.
Yeah, by Benicio del Toro.
Oh wow.
By Benicio del Toro, the guy with the lovable real monsters.
What about Waterhorse, Sarah?
Yeah, but that's supposed to be terrible.
Anyway,
Yeah, terribly good.
anyway, I don't care what you say. Shape of Water was spectacular, but we're not talking about that right now. It's tied for the most Oscar nominations ever, I believe. Yeah.
Yes, I'm
It's been like sweeping the award season.
That just makes it critics like it.
Fine, we're not talking about it anyway. If I can't have the last word, we won't talk.
Victory.
Those depositional basins do have a lot of debris, and it's important that we clear something up. Our first layer to build a deposit of fossil fuels is some sort of silty soil with a high concentration of organic material, like 60-40. It's mud with goop in it. Like imagine the bottom of the Santa Barbara Harbor. That's sand with human poop and chopped veggies from everybody who lives on their boats, plus all the stuff that like washes off the parking lot into the, plus all the concentration of like seals and sea lions that hang out in the harbor, plus all the algae scraps and fish guts from all the fishing boats. That's what's in the bottom of the harbor, but that's obviously mixed in with sand and debris, right? So that's the beginning. Please look up. If you're gonna build this very spectacular rare sandwich of ingredients, you start with this bottom one, and you're gonna need this vocab, I think it's number 19. Source rock. Which is some fine-grained, organic soil like you'd find at the bottom of a swamp or at the bottom of the harbor. Yeah, bro.
Is it also called shale?
No.
No.
So shale can form from this.
Okay.
It can become a shale.
So source rock is just like organic.
Yeah, it's going to become rock later. You all know that sediment becomes rocks, right?
Yeah.
For God's sake, everybody knows the thing with like the different layers of rocks, sedimentary rocks. Okay, yeah. So if you start with something that's rich in organics, when that becomes rock, if you squeeze out all those organics into like a thin layer, that can become fossil fuels maybe. So we're kind of getting started for this. Now, I'm going to give you the recipe to make fossil fuels, but you got to realize that's about a 1 in a trillion never going to happen situation. Imagine this scenario. Jose goes to the grocery store, loaf of bread, jar of peanut butter, jar of boysenberry jam, drives home, gets out of the car. I'm old and stupid and clumsy. Trying to walk around my truck, I trip on my trailer hitch, and I throw my groceries into the air. The peanut butter and the boysenberry smash into each other, shattering the glass. By some unbelievable miracle, a piece of that glass cuts through the bag, releasing 2 slices of bread out into the wind.
And they get caught in between.
And somehow, a glob of peanut butter stumbles into a glob of boysenberry. And through some fluke of wind and gravity and circumstance and rare odds, I right myself, put out my hands and catch a peanut butter and jelly sandwich. Like, that could totally happen, but not a lot, very often. You can't depend, that's not reliable. Like, if you go home and try this, you're just gonna be like, oh, man. Because globally, every time that you have a depositional basin, when you turn around and wait a couple 100 million years and you look back, it's just dirt and rocks. Fossil fuels are really weird, like, voila, the sandwich. And you have to use that fake French accent when you say that. I have a visual to remind you of. You've all seen this. You're walking at the beach on wet sand. Near the water, wet sand. And you stop walking, your tremendous body mass squeezes that wet sand to displace water that makes like a halo around each of your feet. How many of you are familiar with this phenomenon? For God's sake, every child in the world raise their hand right now. You don't have to be Tatanka, like 140, 150, 170 pounds pushing down on wet sand is going to displace some of that water, and that's going to rise to the surface. That's kind of what happens to make fossil fuels. You get a whole bunch of rocks on top of the source material. That's called the reservoir rock. So this compresses the bottom of the bay or the swamp or the deep sea canyon debris and squeezes it so that all the organic soup kind of blends in between the rocks. This is super critical later, I swear. Every student's like, bro, this was so boring. But this is really, really important down the road. You can't make sense later if you don't know this stupid detail now. Nice. I love getting a little peek at the head game of my teenagers. They're just crying out to dance. Bro, I got you. Do this. Follow your dreams.
Thanks, man. Where'd you go?
Here's a totally critical, life-changing detail. I'm glad Ryan came back for this. Here's a totally critical, life-changing detail that changes everything about all conversations about petroleum. Petroleum is found as an impurity in rocks. It's like a bucket of gravel with peanut butter in it. It's like an impurity in rocks. Like if you make a cross section, like I have bookmarks that were made by a geology dork. And if you make like a cross section of this rock, you see like sedimentary rock layers. You see some like bigger chunks of rock. And then in between a few of those, there's like this little black, like little tiny like squiggles. That's the petroleum. This really matters. I swear it really matters. Here's the visual that we all have until this moment. Like I had this visual. I got a tour of a petroleum field once, and I learned something new. We visualize that somewhere underground is a pocket of petroleum. That it's like a buried whoopee cushion, like a water balloon. Or if it's bigger, like a waterbed mattress or a huge water bag full of petroleum.
Is it mixed in the rocks?
But exactly, like if you want a visual, like a bucket of river rocks with peanut butter, where the peanut butter is the petroleum. It's just an impurity of rocks.
But it's contained too, though.
It is contained, that's right. All that organic material would have been eaten if it didn't get covered up by something, and that's the third part of the sandwich. It's called the cap rock. So maybe you had a deep sea canyon and then an earthquake filled it in with rocks, and then changing currents made a waterfall of sand until the worms couldn't reach the goods. Okay. Or you had like a bay out in the ocean and like a tidal wave smashes into the coast and the entire coastal cliffs fall on top. and then some layer of sediment piles up so that the worms can't get to the goods anymore. Now we're talking. Okay, that's how it works. Building these sandwiches never effing happens. It's just a total fluke of geology. It's a mistake, like Homegirl said. Yeah?
So how do you think that the oil in our area was made if it's such a...
I'll bet you people know, because when you cut through the rocks, you can see how it formed, but I don't. One way or another, you had a bunch of organic material blended with sand, and then it got kind of crushed with like chunky, rocky stuff. And as all that organic material was kind of sweating out and the settling was happening, something else went and just buried that so deep that like the worms and the crabs and the hydra couldn't get down there. And then you keep adding sediment until the heat and the pressure builds up and you start to massage the Legos and you get longer chains. And you just wait like 300 to 700 million years. No big deal. And then when you look around the map of rock on the planet, there's a couple little blips that have like petroleum or natural gas or whatever. And those are good for us. That's nice. That petroleum is really handy. It does a lot of work. Want to know something funny? If this was gasoline, the work potential is equivalent to about 12 hours of human labor. Look at this, look at this. 80 cents of gasoline, or keep this a-hole alive for 13 hours of work. Hi.
No, nothing's wrong.
13 hours of work. Imagine how much that would take.
13 hours.
Yes. Like, imagine how much that would take. I gotta feed him like scrambled eggs and bacon and like, okay, get to work. And then like, here's some water. And like, oh, your back is sore. Okay, I got you, buddy. Go ahead and get back to work. And then like, okay, you know, that sandwich break, like 12 hours, right? Like how many of you can work 12 hours straight? A little power bar, have some oranges. Or like, bro, 80 cents. Like the gas tank of my Tacoma holds 17 gallons. I'm gonna use that up in 4 hours. I would need like a team of like 90 slaves to do that work. Or I can just go to the gas station and pay like 40 bucks, sweet. Like the potential for fossil fuels is obvious and a no-brainer and it's not a mistake and every human is doing the smart thing by using fossil fuels because it's a really concentrated effort per dollar. It's a no-brainer. So we're gonna try to get this. Yeah?
This is what they were talking about in the movie last night where it was like, once the gasoline gets like $50 a gallon, it's like actually reasonable.
Yeah, because you gotta wonder like how long, okay, so for 50 hours of work, it's actually a lot more than 50 today, but yeah, there's a tipping point where now it's worth it to pay the unions again. One quick little detail before we go gather all of these fossil fuels. Do you all realize that a teeny trickle of organic material becomes rock, most of it stays alive? That stuff that becomes rock will come out again someday. Volcanic eruptions, erosion of a mountain. My favorite, when the Earth's crust cracks and exposes fossil fuels, lightning strike can light them on fire. So there was a story of some dude on horseback. Is this how you ride a horse? Some dude on horseback, like riding through the Dakotas in a snowstorm. And he like comes over a hill and sees hell, just like flames in the snow, coming out of this like red hot black rock. And he's like, so he goes, yo, and he like gets out of there. One way or another, all this stuff goes back into play. In the ocean, it like comes back, chemistry, calcium carbonate, carbon atoms, I don't know, it goes back into play. But we see the obvious potential to do work, and so we're gonna go get that stuff now. Yeah?
You know that giant pit that's been on fire for like... Yeah, what is that?
No.
It's like
It's a Forrester vocab word, the derby.
No.
it's like it was like an abandoned oil pit in Turkmenistan that some dudes just decided to light on fire, and it hasn't stopped burning for
Yeah.
like 50 years.
Is that...
What's it called?
Yeah.
Derweed.
How do you spell it?
DERWESC.
I think it's abandoned oil.
Or WESC.
Sure, it'll come up.
It'll autocorrect for you.
Yeah.
Derweed.
Yeah.
Yep. Yeah.
Is that how it works?
Yep.
Oh.
Yep.
It hasn't stopped raining, so
Yep.
Yeah. But it won't.
So that's the idea. You know, volcanoes will just make this all into gases, or randomly the Earth's crust will by some fluke get a crack and a weakness and tectonic plates stretch sometimes, or when they smash into each other they ripple, and yeah, lightning strikes it, or some dumbass throws a lit match, and then
What's this?
like you can walk up to the La Brea tar pits, drop a Molotov cocktail, and once that thing starts burning, the La Brea tar pits will be a Darwees forever.
Oh, I'm so
Ooh.
down.
Please don't do that. Please don't do that.
How has no one done that yet?
Yeah.
Yeah, how has no one just been like, hey, you did about that?
See? All right. But like I said, yeah, it would all go back into play eventually, but humans are going to go get this because, like I said, it's a very wise use of our energy to find cheaper energy than feeding a human. Sure, bingo. So this is valuable. Do you want to do human work for less than human work? Let's just get it out of the ground. And watch this. If this was the right visual for a petroleum deposit, right? If it was a solid body underground, this would be such a piece of cake. You would simply drill down until you go pop, and then that's a liquid surrounded by hundreds of millions of tons of rock, right? So it would just go crush, and it would go, and it would just squeeze all that out onto the surface. And that settling of rock would make a depression that would fill up with juice, and that would be a piece of cake. And our climate would be different, and our economy would be different, and this lecture would be short. But the part I gotta remind you is it's not like that at all. Remember that visual about the bucket of river rocks with the peanut butter in it? So how the hell do you think we're gonna get that out of there?
Pump it.
But how are you gonna pump it? What are you gonna do? Suck it out of a solid space?
No, push things in, push it out.
Oh.
Nice, Katie.
So get ready, because this is number 20 something. 21. If you've ever seen like old newsreels or Bugs Bunny cartoons or There Will Be Blood, the Daniel Day-Lewis movie that was made about a Cormac McCarthy book, that was a beautiful book and a decent movie. You've probably seen some sort of a visual. Maybe you heard about the Carnegie family. I hear that there's a teacher who talks about this.
Yeah.
Where people like dig holes, and then they go, oh, and the ground goes grumble, 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 and petroleum starts to bubble out. And you got some hard-working young white guy in the desert that's trying to run out. He goes, starts shooting petroleum in the air?
That happens in the.
That happens in the movie, and that it kind of happens in real life. That's true. That's just.
Over.
Yeah, exactly. Like the ground goes settle, and all those little rocks go. And the peanut butter goes. Bloop, and that's all you got. And then the rocks are just settled. You still got a bunch of rocks covered in peanut butter, and you get a teeny little bit out. Okay. That's the first phase right here. It's called primary extraction. You can see there's not that much. Primary production, where you just make a hole in the crust and the peanut butter comes out on its own because the rocks settle in the bucket. And I hope you don't mind, I'm going to keep saying peanut butter because I want you to visualize something different than you were visualizing before. If you keep thinking about a barrel of oil, you're making a mistake. Yes?
How did they first discover fossil fuels and how they can be used?
Maybe like the Darweezy? Or somebody's like, yo, those rocks are on fire. And like, yo, those rocks are still on fire. Like, holy crap, those are really hot rocks. And somebody's like, yeah, I got one of those. And you go, whoa, it's hot. Something like that. I wasn't there. I haven't heard about it. You gotta know that number. Look at that number.
Jeez.
Can I?
just
I have 25.
Oh, yeah, right, because your book defines these a little differently. So that number, no, the 5 to 15 refers to all primary extraction, including how we did it back in the day. Your book is how we do primary extraction now. It's a little fancier because we got smarter drill bits and stuff. So now in primary extraction we can get 25, but in the history of petroleum, we would get less of what's down there. And then, Katie, what were you saying? How are we going to get the rest of the petroleum out before you go?
You put stuff in.
Yeah. It's called enhanced because now you have to use energy to do it. It's called enhanced because now it's work. Everybody knows that oil floats on water because you've heard of oil slicks, and you see what happens when you wash the driveway, you get that rainbow shimmer on top of the water, because you know that oil floats on water. Maybe you did the trick with the olive oil in the water when you were in the 2nd grade or whatever. Maybe you mix your own salad dressing. You don't have to copy all this, but I'm getting ready to move it, so. How many of you have seen these things on the side of the road? Like when you drive up on Highway 101, they're like in the Paso region. There's like a big field of them. You see them in Fresno.
Mm-hmm.
You know, you might see them in Beverly Hills, actually, surprisingly. Beverly Hills. And where did O.J. Simpson live? Starts with a B?
Brentwood.
Brentwood has a bunch of these.
Really?
Yeah.
Long Beach. They're in the parking lot.
All BC has a bunch. That's true. That's true. And H. Brodog. How many of you thought that they were all going and like sucking stuff out?
Yeah.
Reasonable, right? Wrong. They're actually doing that. They pump the water in. This diagram drew it in the wrong place. That little perpetual motion drinking rooster thing. Those are pumps that pressurize water. And everybody's going, and you're like pumping water underground. And when you build up the pressure, on one of those wells, you let the cap off. And it goes, and it like just petroleum comes out because it floats on the water. So the water's riding through the gravel, and the petroleum's getting squeezed out, and then you go bloop, and it goes, and like a little bit comes out, and you close it again. You build up all the pressure, 5 to 1 usually. 5 water injections for each.
Can you keep doing this process over and over to get as much as you can out?
Until water starts coming out, and you've basically cleaned all of the passageways with water.
But then wouldn't that be 100%
Nope.
and not 30?
Nope. Because don't forget that the petroleum floats on the water. So any place that you have a rock shape like this, you push water through it, where's the petroleum going to go?
It's going to scrape up. And
Right. And don't forget, there's a whole bunch of displacement by air pockets in there too in the natural gas that we're talking about. So all of those things are like the water scooting here. Plus, how much of that rock do you think you can actually push water through? That petroleum is so thick and goopy, right? It's like at 38 degrees or whatever it is, 1,000 feet underground, right? Plus it's under tremendous pressure, so I think when you pressurize it, it probably becomes goopier. I'm just guessing. Yeah?
With like newer technologies, could they extract and pump closer to where the collection would be?
Yeah, so we can keep trying. Can anybody imagine what else you would do now? What else?
Go back to the original places that they started getting oil from and get more out?
Okay, but before we give up on this one, what can we do?
Pump all the water out.
Yeah, and then what? You're still just left with all the petroleum down there. Nobody wants that from dirty water. You leave that down there.
They didn't practice.
Nope, not yet. How are we gonna get that petroleum out?
Blow
It's
it
not
up.
rocket science. You've got all the tools you need.
Blow it up.
No. Make an explosion in the petroleum. How do I empty this gas tank? I put dynamite. You're supposed to know this. What happens to like oil when you put it in the refrigerator?
Free?
Yeah, it kind of gets solid. So what can we do to get more of that petroleum out?
Heat it up.
Heat it up a little bit.
Yeah. We could inject heat of some sort, steam or fancy chemicals.
Isn't this not used a lot and then you just leave the last like 15% in the ground?
Well, I don't know how good you are at math, but 15 plus 30 plus 15 is 60. At the very least, we'll leave 40%.
Yeah. It says final 15%.
Yeah, final of what they can get.
Okay.
Back.
Because you know, you got your 5 to 15, and then you got your
Yeah,
15 to 30, you got 5 to 15 again. Yeah, I know that guy. He used to be in my class.
It still only gets 5 to 15%.
Yeah. And I want you to imagine how much work you got to do. Let's go back in time for a minute. When you did the primary extraction and you dig a hole and it comes out of the earth on its own, please look up. You need that much petroleum energy equivalent to get a barrel. It's about a quart of energy to get a barrel of energy. Primary.
That's good.
Yeah, because you're just like ding, 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 and then you just like print money for a couple of years. It just comes shooting, and you're like, yeah, rich. So that's the Carnegie, the Bushes, all the Rockefeller, did they do petroleum?
Yeah.
Yeah. So you can, easy money. You just figure out how to be the first guy to get the easy money, and you show up and you go bang, 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 and they go, whoa, and then you just start putting it in barrels, you just make money. Yeah.
So, if you said it's like 4 to 7 miles inland and the reservoirs underneath us, is it underneath like Santa Barbara too? Or just underneath in the ocean?
It's possible that, I don't know if there's any under Santa Barbara right here, but the Mesa used to have a whole bunch, yeah.
And do they go on land to get it out? Or
Sometimes. We'll come back to this, yeah. I want to keep thinking about the different stages of production, though. In primary production, you're spending a teeny bit of effort to get the petroleum out. Now, the rest is still down there. You're like, oh, man, I just can't reach it. So, yeah, we'll set up all the pumps and all the plumbing and all the pipes, and we'll drill a whole bunch of holes so that we can build pressure and we get more petroleum out. But you got to realize
that takes more energy.
That takes a lot more energy, takes more money, right?
So you don't get as much out.
So either it's less profitable, or you got to make the petroleum more
So they're
expensive.
just adding a bunch to put more water to create more. Do they know which one it's going to come out of?
I assume that there's probably a bunch of nerds doing a lot of mapping and stuff.
So
Yeah.
it's not that efficient if they're just adding more.
It's not like a total crapshoot, but it is a lot of work.
Yeah.
Check this out. Secondary extraction is about 1 barrel spent for every barrel you can sell. So you got to feed the chef in order for him to make a meal. So now that you're going to sell that, you got to pay for that food too, right? That doubles the price, or it halves the profit. Does that make sense to everybody? Because when half the petroleum you get out is your operating petroleum, and the other half you get to sell.
Mm-hmm.
Right? Now that we got to start heating the stuff up,
That's more energy.
you got to use 2 barrels of petroleum for every barrel produced.
So why do they even do it? Just waste it.
Well, because you can still get it. It's just,
You just sell it.
you're only selling 1/3 of the deposit, and you have to use 2/3
But you would sell it for more.
to keep getting it. But now you got to, that's right, the price is higher because you got to cover all that cost anyway.
So usually gas prices will go up when we have to spend.
That's right, that's precisely right. The price goes up and the environmental impact goes up. I burned 2 barrels of petroleum, that's a lot of CO2 before you get to put it in your car, right? Imagine if you go to a restaurant and they're like, it took 6 chefs to make that meal. You're like, holy crap. I gotta buy all the food for 6 chefs just to get my 1 meal? That's gonna be a really expensive plate, it better be good. Imagine how much heat it takes to keep the steam hot after it goes through a pipe in the deep ocean for 1,000 feet and then goes underground for that to still come out steam.
A lot.
Thousands of degrees.
Like, I don't even know how much energy we have to use for this. And we gotta do some wacky chemistry for like heat retention. I don't know what they do. Like, you all realize that like your water heater is like 60 feet from your bathroom, and when you turn on the water, it's already hot over there, but you gotta heat the pipe for a few minutes, and so all the water that comes out is cold, because all that heat was lost in the attic before it reached your house. It was your shower. You understand that, right? Now imagine how much you'd have to use to get hot water to reach 3,000 feet under the Gulf of Mexico, for example. Or 900 feet under the Arctic ice caps up in Alaska. Yeah.
how do they find these deposits? Do they just kind of hit or miss? Like,
No, I mean, there's like mapping of geology. There's like sonar that you can use. And like, there's a lot of stuff that you can see on the surface. Like, oh, well, we have a lot of sandstone in the hills, so this is all sedimentary. So now that you know it's sedimentary, maybe he's got to find a pocket that has a mistake. So which way do they go, and where's the old stuff, and where have they shifted that's likely to, I don't know. Tell me if you know these places. Rincon, Little Rincon, Muscle Shoals, Arco Island, Emma Wood.
Mm-hmm.
The beginning of Ventura, where there's like that big bridge and you make a left. All right. From Rincon all the way to Emma Wood is almost entirely owned by a petroleum company. They own those 4 and those 3. They all have pipes that meet at Arco Island, where they separate the natural gas, the petroleum, and the dirty water and the clean water. All those pipes go underneath that bridge to the Muscle Shoals community, and there they go underneath the freeway, and they go across the street into the hills, Where now that it's burned, if you look left when you're driving to Emma Wood, you can see these switchbacking roads and a whole bunch of these things. There's your diagram.
Isn't that Veneca?
Yeah, I believe it was Veneca. I think
Yeah.
that's the name now.
That island's getting shut down, pretty sure.
Yeah, they're trying to sell it. $14 million.
Yeah.
Private property. You can make a house there.
Yeah. Why are they trying to sell it?
Because those are shut down. It's over. It's a bust. All that stuff, we're like, I just can't get it anymore. It's like, and like if we could sell that stuff for $250 a barrel, like great, I'll just keep spending petroleum until I can reach it, and then we'll be able to sell it for $250. But right now the global price of petroleum is like 60, 70 bucks a barrel, and the forecast is 80 or 90 for a decade. It's just not worth paying the rent on all that land. So they're going to cut losses, they're going to shut it down. That's your whole field right there. You've got like petroleum blobs, and you got to inject the dirty water and get rid of the crap water and get some petroleum out there and hot and cold stuff and where you separate it all. That's how it works. It's a whole landscape with a bunch of little holes trying to wash a bunch of buried gravel of all that peanut butter that's stuck on it. Yeah?
Are they all commonly at the same depth? Or
Yeah, wait, sorry, what?
Are all the pockets at the
No.
same? They vary.
Sedimentary rock is really unstable. It's usually pretty old, and it's usually not very cohesive. You know about sandstone that's generally soft. Coincidentally, ours is exceedingly old, so it's had a lot of history. It's wrinkly old skin.
So the pockets can just be at any depth.
You know that they keep leaking. That's why we have all those tar bombs on the beach. Kai, will you please turn on the lights? I want to show everybody a picture. I'm glad that you're all seated toward the front because you get to see something super cool. I know that a lot of you don't live in Santa Barbara, but if you're a Mesa Loke, you're going to love this. Cliff and Flora Vista in 1929. So,
Wait, what year?
Where's the hill?
1929. This is Monroe. Behind you is Flora Vista Hill. This is Albertsons or whatever. I don't know what it became. Bonds. So, like, if you look right there, that's the stagger where there's those two stop signs that are separated by like 20 feet of asphalt on Cliff. You know what I'm talking about?
Yeah.
So that's right in the middle there. And then if you look at that street going off into the horizon, that's Mesa Lane down 1,000 steps. So check that out. In 1929, there was like 3 houses on the entire mesa, and it was all a big oil field. And the petroleum companies in 1929, somebody had already figured out the heating thing, but it wasn't worth it. I think that they probably did pump some water. I'm going to assume that they were pushing water in secondary extraction.
From the ocean?
But I would assume there's a lot of water there. But I don't think that they bothered with tertiary. They were like, well, this will be really good real estate. Who cares? It's going to be too expensive to get that stuff. Nobody's ever going to pay 30 bucks a barrel. So they left it. And they covered it all up, and they sold it, and y'all got houses there, or people got houses there. The Hep family, Mulwood, the guy that besides Paul, the Trigueros, the other family. My wife knows a lady who lives right next to Monroe, and one day she's out weeding her carrots, and she's like, and she looks, and there's like petroleum bubbling out from underneath her foundation. So she's like, is this supposed to do that? And she called her realtor, who called the other realtor, who calls some guy, who calls some guy, who calls some guy, who called the guy that had the petroleum rights. What are you doing?
Yeah.
No. No. No, don't just cover it up. I'm here to ruin your stupid games. I hope you lose. Did I make you lose? Is it over? Have you lost? It is my mission. You can just be absent.
Okay.
Okay. And you'll still lose. Okay. The lady called the petroleum company. They come out, they drilled a hole through the roof, through the granite countertop, through her kitchen cabinets, through the foundation. It goes boom, 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 boom. House starts to fill up with petroleum. So they go like, they like put it all in these big marboard containers on the front lawn. She had like a big fence around it. Some kid in my period 3's like, period 2 is like, oh yeah, I remember, I live right near there, I remember when they did that. And they were just like filled up containers with petroleum until they got everything they could get out of there. And then they like poured in concrete and covered it all up, and they gave her like a fabulous remodel. And she's got the really nice house that looks kind of like salmon-y orange colored with like new stucco and like the Spanish style roof. And it's got like a little porch that comes out toward the street.
Probably made some money on that.
I think that her house appreciated significant value. Yeah. You know, she was put out for like a year and a half. And, yeah, she was kind of bummed, but then she moved into this house again. She's super psyched. It's all down there. Here comes the sad number. Most of it's still there. We just give up on it because it's too difficult to get it.
Do you think in the future they're gonna find an easier way to get it and go back to all these places that are already covered up?
I think it's a really good question, and I do plan to talk about that. Hurry up, if you were going to do something, this would be the time. I'm about to move the slide. 5, 4, 3, 2, here I go, I'm going to move the slide. Look at that. That whole circle is America Petroleum, the whole total, okay? That's all the petroleum there is. And the 183, the salmon, the quarter in the upper right, that's all the petroleum that we ever took out of America. All the gasoline, diesel, jet fuel, tankers, home heating, tar, asphalt, all the stuff that we use to make all the plastics and stuff, that's what we already got. That's American production in the history of America. Give or take a decade, okay? It's probably a little outdated. And then look at that yellowish, greenish, weird, gross, rotten banana color. That's all the stuff that we're like, just couldn't reach. Of that, more than half is straight up abandoned, like the Mesa. Like, well, nope, that's not even. So all that on the left, this part, that's like the Mesa. We gave up on it, screw it. There's a little wedge left where we still own somebody. There's like a petroleum company that's like, yeah, maybe I'll come back. To answer your question, like, well, right now it's not worth it, but if petroleum prices go up, I want to switch on the electricity and hire a crew. We're going to put the machines in and get to work again. Okay? Now look at this. That's the petroleum that we could still get that we know about. That's called the proven reserves. So like all the stuff underneath the preschool that we don't want to mess up, the coastal shelves where we don't really want to drill, the Alaska National Wildlife Refuge, which until recently was protected from drilling. That's the blue stuff. And you can understand why people want to get it, because you show up and you punch a hole and it's easy money. At today's prices, spending a quart of energy to get a barrel of energy is just so profitable. So all the petroleum guys are like, come on, come on, come on, let me just drill the preschool. Come on, I want to drill the preschool. And our last president, he was like, nope. We'll give you some more of these back, but you got to go back to where we already made a hole and work harder for it. You're like, come on. That's not the profitable stuff. New president? Aw, dude, do it. It'll be great. So we just opened up ANWR. We just opened up all the coastal waters except for Florida, where those people vote Republican. And we're going to get this little bit. Cool. It was going to happen sooner or later. I've always said it's going to happen sooner or later. It's a pendulum. Politics, I don't really give a crap. There's a little bit that we know must be down there, but we don't know where it is because statistically we just haven't mapped it yet. So, you know, there must be some there, we just don't know where. There's got to be some gold in there too, we just don't know where it is yet. And then there's the stuff that we know must be down there, but we probably are never going to be able to get anyway. There you go, that's America's petroleum. So I got a couple of minutes to answer this question, and I want to do that quickly. What?
I was just wondering if that could become protected if politics sway back before they have a chance to do anything.
I think it could. I think it could. Look, I got a few minutes to answer what I think is possibly one of the more important questions in your lifetime. Like this is I think a question which does matter to your generation. Like bro, like this is actually whatever politics you have, this is your choice. Like really, like you know, petroleum companies make a lot of money. Like if you rely on those, that's a defensible opportunity. I'm not. But get your facts straight. Peak oil is the theoretical moment when petroleum yield starts to go down. Watch me. More petroleum, more petroleum, more petroleum, more petroleum, and then, oh, we got less petroleum. Holy crap, we're getting less petroleum. That was peak oil. The moment where the supply starts to go downhill. Because, you know, that would suggest you've started to run out. You know what I mean by that? Peak oil?
No.
Here's the wacky thing. What?
Say it again.
The theoretical moment where petroleum yield starts to go downhill. Where the supply of petroleum starts to run out. Let's say it again. Good.
But we're on the downhill right now.
No, it's debated though.
So here's the wacky part. The hippies say, dude, 1970s was peak oil. And then today, all of like the bankers and the investors, they're like, well, give or take a decade. We're like, you know, depends on your president. And that's correct. They're right too. But you know, you ask all the people who own Shell Oil and Beyond Petroleum and Chevron and all them, and they're like, nah, man, 2100, 2200, you'll be dead before peak oil. And get this, they're right too.
It's between discoverable oil and like attainable oil and like what you describe as oil, right?
And how much you use.
And how much you're willing to pay for it.
Yeah.
And how hard you're willing to work for it. Back in the day, people made a ton of money on really cheap, easy to get petroleum that had very little environmental impact, because you had to barely spend CO2 to get it out of the ground, and that was super profitable. And BT dubs, in my grandfather's generation, energy was a tiny wedge of the federal budget. People spent very little money on energy. Okay? In my dad's generation, you had to spend a barrel to get a barrel. So the carbon cost of petroleum roughly doubled because of all that production work you had to do with all the pumping of water. And you had to spend a bunch of water and use a bunch of land for all the plumbing and the holes in the ground and all that crap. And that was actually a bigger cost, and it became a bigger wedge of the American economy spent on petroleum. We go to today, my generation, we're spending, like, starting to push now 2 barrels of petroleum to get each barrel of petroleum. The American budget is more and more for energy. Of all the money in America, you and me and all, we're like, how much for a gallon? Okay, whatever, 4 bucks, 5 bucks, 6, fucking gasoline, fine. You know what's crazy? Evidence shows you're willing to pay even more for energy. So we're not gonna run out. We're gonna spend more for it, and we're gonna pollute more to get it. That's the stuff on the right. Like, if you want to keep going, you just, like, if you pay me $1 billion a barrel, I'm going to shove my kid down the hole with a toothbrush to clean all the peanut butter off those rocks, right? I'll be like, come on, Toby, you want to go to college? Grab a toothbrush, kid. Take the elevator, bring me a barrel. We'll do whatever it takes, right? If I got to, like, burn babies to get it, like, all right, $1 billion. $1 billion, bro. Burn a couple babies and then you retire. I'm down. I don't care. $1 billion?
So, if you you use 2 barrels to get 1 barrel, aren't you wasting more petroleum than you're getting? Or I don't really get that.
Of the stuff you get out of the ground, most of it is still going back to the facility to keep working.
Oh, okay,
So you get to sell a very small percentage because you have to use most of it.
okay, that makes more sense.
Okay? So like, if you're a farmer, you grow food to sell, but you gotta grow some to feed you. And maybe you gotta grow more to feed your workers, and you gotta grow more to feed the whole village. If you can only sell 1 head of lettuce, but you gotta feed 48 workers, you're running a big ass farm and you're only selling a real tiny bit of your lettuce, right?
So it just goes up in price.
So a whole bunch of it is the production cost of making that one for sale, and it becomes really expensive now, right? How many of you find this new information in this conversation? Do you feel that you're more prepared? Like, this is kind of interesting. I feel like I know something I didn't before. Remember the thing about how petroleum is not a contiguous deposit? Mixed in with rocks, fluke of geology, peak oil is irrelevant. There's always going to be more if we're willing to keep burning babies for it or whatever. Okay. Duggan, will you please press stop stream?